So just let me know like if you guys can see my screen. Just ping me yes no. So, so my screen is visible, right? Okay, fine. Fine, Ritushri and Shubham. So, so let me just give me a brief about myself. I'm Zishan, and I did my bachelor's and master's both in statistics, and currently working in insurance analytics sector. So, this session would be based on logistic regression, basically. So, like as previously, we covered the entire end-to-end implementation of linear regression in R. So this particular session is based on logistic regression. It's just the transformation of linear regression. Basically, there we try we try to predict or forecast a variable which is very numeric in nature, and here we try to predict outcomes which is a category in nature. So I'll just explain more about it, but before moving going into depth of that, let's understand the concepts and the data set, most importantly. So like I'll just give you a brief, and then we will start with objective of this session, and then we will go to the depth of data, basically, since this is a very live data, and this is a very famous data as well. Basically it's a Titanic survival prediction. Basically it's a very live data. I'll just try to relate that as well, and then we'll just try to like import the data, and then we'll see visualize the data, each variables, and then again the concept of training and testing set would come into play, and then we would try to predict using logistic regression, and I'll just explain the explain you the all the arguments used in that. Okay, fine. So here, like in this data, basically I'll just close these tabs here. Fine. So since this is like the procedures of any algorithms, basically, whether it be linear regression, or whether it be logistic regression, or whether it be decision tree and so on. So the procedures always remain same, right? The objective changes. So the procedure, again, if I repeat, like I'll be getting a working directory, and I'll be setting my working directory. Fine. So now I'll just install the library called Amelia, and I'll call it through a library function in R. So this library and installation is all like clear, right? It's like very basic, and I think this session has already been taken. So it's generally installing the package and calling it through a library function. Fine. So now let's come to a very objective of our like today's session. So basically we need to predict, predicting the survival of a Titanic passenger. So have you guys remember or have seen a movie Titanic? So which had it was a disaster kind of something. So we have a live data of that. So let's come to the data set, and I'll explain you, and I'll let you know how live it is. So I'll just call a read.csv function of R, and I'll just give my data set name, and I'll just add the argument, and I'll say the R function that yes, there is a header in the data, and it's true, we have to consider that that headers as well. Fine. So I've just read that data in R. I've just imported basically in the data in R, and I just try to view that data. So like yes, now viewing that data is a very important task. You have to keep in mind all the variables which is in our data, basically. So here, let me just give a brief and in-depth knowledge of the variables or the columns we have, and after that I'll just let how we, through a judgment call, basically we can just remove the variables as well. Fine. So the first column itself says that it's a passenger ID. And what is passenger ID? Basically the question is, what is passenger ID? So the passenger ID is basically a unique identity given to a passenger, to every passenger. So there's a variable called name here as well. So if you see, name can repeat, right? Name can always repeat, two-person can have one name, right? So this is the unique ID uh, to given to every passenger, okay, through which we can easily identify basically, okay. So now the next variable is a very important variable, and it's a survived variable. Basically it is a category of 1 and 0. It says if a passenger is survived, 1 or not, that is 0. Fine. So this is our like objective, this is our outcome variable. We have to predict this variable, whether a passenger survived or not, 1 and 0. Fine. The entire variable has the value 1 and 0, okay. So this is very important variable. Coming to the third variable, it's P class, and P class stands for passenger class. Passenger class is basically, like, let's understand this way. So if you travel in a train, there is a class, right? First AC, second AC, third AC, and so on. So that's the same concept here. It's a passenger class basically, first, second, and third. Okay. So the other variable here is name. So name of the passenger basically. Okay. The next variable is sex, and which is male and female. The other is age, which is the age of the variable basically. The other variable here is like SIBSP, which means sibling or spouse not in a boat, like outside the boat. Basically, if I'm in a boat or I'm in a Titanic boat, so how many siblings or how many spouse is outside the boat, or basically they're residing outside the boat basically. Okay. So if I'm in a boat, so I'll calculate like how many siblings and how many spouse are outside the boat or residing outside that outside the boat. Fine. So the other variable here is PARCH, which means parent and children. PAR means parent and CH means children. So again the same concept goes there, like how many parents or children is outside the boat, residing there outside. Okay. So clear. Fine. So guys, remember, like, if I'm asking you, is it clear, not yes, no. So if no outcome comes, then I'm just assuming that you guys are getting the points. Okay. So now coming to the next variable is ticket. So it's a very general or traditional thing. It's a ticket number in train or in flight or in any other ship maybe. So there's a ticket number we get, right? So that is the or that's the column. So fare is nothing but the costing of a particular ticket, and cabin is like, if now coming to a cabin variable, it's very important variable. So now let's analyze this variable a bit. So I have a cabin details available mostly for passenger first class. I have a few, but mostly I have cabin details for only first class passenger. Can you see, guys? Can you just analyze this? Can you just visualize this? Like, we have details only for like, not only but mostly for like first class people. So here I am getting like one which is the cabin details of third class people. I mean the class 3 people basically, and others like mostly there are details of first class people. Okay, the class 1 people basically. And these tickets are basically very expensive. If you see the first class class 1 ticket, it's very expensive. If you see class 1 ticket, it's very, the numbers are increasing. So like it's like the the thing which we have in train basically, class 1 ticket is very high, right? So that's the basically catch here. So now embarked is something from which city or from which place you have boarded, and this is only it is it is a category basically. So here I am done with the data set and the description of column. So I'll be just explaining you how many number of rows and how many number of variables we have. So when I did run this command, right? I did run my data set, and I can just go and see the uh, you know uh, like uh, details of number of columns and number of rows in global environment, and I can see that 891 observations are there, and with 12 variables, 12 predictors basically, not 12 predictors, basically 11 predictors, and including one dependent variable. So guys, like I'll be going into more depth of this data, and I'll be showing you how live this is. So any problem in understanding the column names and variables, anything? Guys, you can unmute yourself and you can just interact with me. It's very good if you guys interact, because it's very it is going to be very happening and interesting in coming like 1 or 2 minutes, because I'll be showing how live it is. Okay, fine. So I'm assuming that you are get you have understood all the data variables, fine. So now let's just go and just okay, okay, Shubham, no issues, Shubham. It's fine. So just drop, but don't forget to drop a chat if you're outside. My main objective is to clear your doubts. Okay, so don't forget to drop a chat. And Ritushri, you can just speak. Okay, so that we can make the discussion a very interactive one, and we can just understand how live it is. Like comparing with the Google results. Okay, now what I'll do, I have just said you right. Let's understand how live it is basically. So I'll just open this data set here, and I'll just go into Google. Okay, I'll just go into Google. Okay, I'll just go into Google and I'll type like names of person in Titanic. So let's understand how live it is. Okay, guys, these are the person who were in the Titanic boat at 1912 when happened, right? So the total person was around 2224, like I mean around 2200 people were there, but we do not have all the data. We somehow have around 900 data points, so we have like we are missing with many people, right? So let's again go back and see. Now just try to understand here, just try to understand, like if you see like many people here ended their life in 1912, like can you see this person, like this person I think was the person who survived the Titanic disaster. Again, most of the people you see, like it's 1912, it's 1912. Now why it's 1912? So around 1911 or 1912 the Titanic happened. So that's why that's why the most of the variables, most of the person died in 1912. It's around 11 or 12, right? So now let's check if these persons are in our data set, because because there are total of 2200 people in the Titanic initially. So we have only 900 people, 900 or 900 observations, right? So we have to find which people are in our data set. So let's start with who died in the Titanic boat. So let's compare, like is it true or not. So let's say Thomas Andrews is like a person which were initially in the Titanic boat. So let's come and search for Thomas. So I am getting a name which is not exactly matching, but I can just try and I'll just show you, like is this the same person which I'm trying to find. So here is this Thomas Andrews, right? And I'm going and I'm searching this name which I got from my data set, and I'm just going into images, and I find that yes, this is the same person, right? This is the same person here it's showing, right? Can you just compare this Thomas Andrews who died in Titanic, and let's say what our data set is saying? Yeah, zero. That means he died, right? Again, let us check for okay. Okay, this person I can see is like survived the Titanic? Margaret Brown. Okay, now let's check for Margaret Brown. Okay, I'm getting another data which is not very similar, but somehow Margaret is there. So let's go and search this person, because this lady survived somehow, because if she would have been dead, so it would have been 1912. So let's check, is that the same person I'm trying to find? I think yes. I think yes, because if you see, Margaret Brown is the same person here I'm getting. And the Google data says that this lady survived Titanic. And let's go here and see, like, is this true? Yes, it's true. It's given one. Can you see, guys? Can you just compare? The data is live actually, right? Any response, please? Yes, no. Okay, there are five people now. Okay, so guys, okay, just hold on. Okay, so other people who joined other people who joined little late, like Kea and Sanchita. So did you understand the comparison I did right now? You can just unmute yourself, guys. Yes. So did you? I just compared the entire data with Google and my data. So it was like a comparison, like, right. So you didn't miss, right? So you got the comparison. Okay, fine. So yes. So I've compared the data. Yes, it's very live. But yes, the point is, the initially the boat was filled with around 2200 people, but here we have data of around 900 people. So because the entire data set is not somehow given, but it's fine. We can just we have just made a comparison that yes, we have a live data. Okay, so now objective, now coming to the objective, coming to the objective. So guys, Kia and like one more person, did you understand, did you join when this discussion was going on, the variable names data understanding? Okay, fine, Sanchita. Okay, fine. So let's now, we can just continue. That means you haven't missed something, like, that's okay. Okay, fine, fine, Kia. So now let's, and the objective is very much clear now. Like, before performing any analysis, before performing any data analysis, try to understand the objective. Here I've got the objective and I've compared the results with Google's data, right? So our objective is to predict the survival of Titanic passengers, right? So now I've read the data, I've viewed the columns, and now I'm asking you a question, you have to answer. Now, seeing this data, seeing these variables, you have to make a call, you have to make a judgment call, we say in industry. And we need to remove variables which seems like it cannot give any information. Like, can you just make a judgment, each of you guys can you just make a judgment, like which variable would give nothing, is basically not significant statistically. Can you come, like, can you judge? It's a judgment call basically. Seeing this data, understanding this data, can you just make a judgment call, like which variable it's important and is not important basically, before performing into, before it's always good to have a judgment call and remove those variable initially, rather going forward, putting all the variables in a model, and then comparing the p values, and then removing those variables, and then running the model, and then analyzing. So that hectic procedure is a bit deeper, but we can just make a call here itself, like which variables are not important. Okay, I'm asking which variable is not significant, which I mean which variable we should drop here itself. Yeah, ticket is significant variable, but we have alternative variable here which can describe ticket. So okay, I'm not asking the significant variable. We will see like in the model, but I'm asking, I'm taking a judgment call, like which variable is not important. Do you think yeah, correct, Shubham. People belonging to different classes will have to different chances to survive. That's very important variable. That's why we'll keep that variable. But I'm trying to make you understand that which variable is not important. Seeing and making a judgment call. This is very well said. Like people belonging to different classes will have to different chances to survive. Yeah, very correct. Because if a class 1 people is getting a cabin with all comforts, it's very high chances that they would survive. So are you saying that siblings are not important or important? Variable looks like unimportant, fine. So let me just give more brief about the variables and how it is not important. So like, do you think any relevancy in passenger id? Like it's serial number given to every passenger. So do you think this variable is important? It's just a unique id given to a passenger. So it's, I think this is not important. So what's your call? So like again, if passenger id and if I see the names, do names anytime can relate anything? Names as well, if putting a name into models, that doesn't give anything, right? So names can be random, right? It's very uncorrelated with the with our survival thing, right? So because it works like that. Coming to the sex variable, it's is important because survival depends on male and female, right? Age is a factor, a very important factor basically. Now here comes sibling and spouse outside the boat, and parent and children outside the boat. So let's make a call, like, yeah, this variable could be important, if titanic is going to happen, then people would get their in mind that yes, I would have people are there outside of mine, and this kind of thought make a person weaker at who's in the boat. So yes, we can consider this in the model. But coming to ticket, again, this is a very random thing, like passenger id. This thing cannot give us any information about survival, or who survived or not. So this variable and fare as well, and cabin and embark is somehow like if you see cabin, so it's around like many it has a bunch of missing value. We have data where we have this data where we have class 1 passenger only, and there is missing data for class 2 and class 3. So keeping this variable is is somehow not important. So now coming to embarkment is somehow the boarding place from where a person is boarding or embarking into a ship basically. So this variable is as well not important. But now coming to fare variable, now if you see a class 1 people has a higher number of fare. So if I consider this variable and this variable, it's fine. But if you consider only this variable, it's also fine. So it's basically works that way. Okay, so fine. So through a judgment call, we can just what we can do is we can just put these variables, we'll drop this variable here itself, and we'll make a different data set. So initially we have 12 columns, 12 variables, and here is the name of those variables in our data set. Okay, now what I'll do, I'll just I'll just use a subset function. Okay, a subset function is, like, we can just filter out the columns through a select argument in the subset function. And what I'm doing is I'm selecting the variables which are significant and removing the variables or dropping the variables which I just discussed like a minute ago, like, like a passenger ID and, like name. This kind of variable is, like for our analysis, because we are trying to predict the survival, is not important. Maybe for other analysis is important, but for our analysis, for our objective, it's not important. Okay, guys, good to go, right? So I've selected the variable and imported the variable and kept that data set, the new data set, in D1, and I'm just running it, and I'm just saying that yes, I'm just keeping these variables in our model according to our objective. Okay, fine. So guys, if you have like any doubts, you can just pitch me, you can ask me. Okay, so now let's explore the variables. Now just exploring the variable is always, very like informative. How? Because, you would be having initial idea or rough idea, like, what variable actually looks like. So if I just use a table function here, which only, do a like bring a table into column. So what it says like, we have zero sibling or spouse outside the board. It like around 60 people. Can you see my screen? It's visible, right? So around 60 people had no sibling or spouse outside the board. That means these people are independent. So around 209 people have one sibling or spouse, and so on. Fine. So this variable is very clear, right? This variable is very clear. Now coming to the next variable, which is parent and children. So again, there are around, 678 people who do not have parent or children outside the board. Again, these people are independent. Okay, so coming again, 118 people, 118 people have one spouse or, children outside the board. Okay, so there's a dependency, right? Okay, so now coming to analyzing the sex variable, and sex says like around out of the entire data set, we have 314 female candidates, female passenger, and 577 male passenger. So yes, we have a rough. Now we are when analyzing the exploring the variable this way, so you guys are having, a bit of rough ideas, like how like the variables are varying and how numbers are varying. If I consider the sex variable, then there are around, 314 lesser than a male, that is 571 577 males, right? You are getting a rough idea, right, about the data set. That's important. Okay, so now in our model, like there's a variable called sex, and which is, if you see here, it's basically male and female. It's a string, right? It's a string given here. So what we will do, we will try to convert this into zero or ones. Ones means male and zeros means female. So I'm just again trying to use mutate function, like of dplyr package, and I'm trying to pass the argument which is our latest data set, that is d1. I'm making a column sex1, and I'm just passing a function, and I'm saying that if in sex, like if male occurs, then assign the value to 1, and if like female or other thing happen, then assign this value as 0. So I'm just running, and I'm storing this in a latest data, that is d2, and I'm just running it, and I'm just passing the functions, and I'm just trying to visualize this, if it is correct or not. So yes, female, according to our argument, female is 0 and male is 577, and it all converted into ones and zeros. So guys, clear till here? I need answers, guys, whether you can text me or you can maybe speak up. Ritushri, okay, fine. So okay, Okay, fine. Now, since we have treated, the variable sex. Okay, now let's come and see and check the outliers, and treat the outliers basically. So I'll just simply plot the box plot, and I'll just try to visualize this. Can you guys see outliers here? So we have these variables, right? We have this particular variables in our data set. Fine. So here we can see in a edge variable, which is a very numeric in nature, it has outliers, right? And we can also see here and here, but we have somehow seen here, when analyzing this thing, this is a simple numbers, right? So and there's no missing value in it. So we would try not to treat outliers of these variable. Why? Because outliers, treating outliers, meaning we have to we will lose information. So if these no other things are happening, like missing value or something, we would retrieve that information. Okay, so now we will come and we'll just try and just impute, we will just try and treat outliers only for edge variable. uh, and if I see and plot the uh, data, and I'll just see, just hold on. So okay, so I'll just try and come here, and I'll see this. Yes, I've imputed, I have somehow removed the outliers of this thing. So now why I'm removing the outliers of edge variable particularly? Because if I see, I see that sibling or spouse and parent or children does not have any missing value, but yes, edge has some missing value in a good amount, right? So treating outlier would be always good. Why? Because if I would not treat outlier, then we have to impute this with mean. So at that time, it would deviate. So that's why I'm trying to impute, treat outliers first, and then I'm removing the I'll just impute the edge variable, missing edge variable through mean. Guys, am I good? Yes, no, anything, you can just keep on texting me. Okay, Ritush, fine. So, Shubham, you there, right? Okay, fine. So now let's just I've seen there, there are around 177 values, which is somehow like yeah. Okay, so I'm assuming like you guys are getting into these things, and you are understanding these concepts, and you're not you somehow avoiding something. Okay, so okay, just I have just tried to visualize the missing value thing, and I've checked the missing value. Like I've seen, yes, there is a missing value in edge variable, which is very numeric in nature. So what I'll do now, I'll treat this missing value, and since this is a very numeric value, so what I'll do, the best approach is, I'll be imputing those missing value in edge variable through mean. So the average value would imputed in the missing value of edge variable. Fine. So it's a simple function. What I'll do, I'll use edge is dot na, and I'll just pass the argument that yes, if there is a missing value in edge variable, then impute those missing value and through me. So that's the basically function is doing, and I'm just storing this in d3 as itself. So I'm just running it, and I'm just saying that there are around 883 number of observations left, because we have removed the outliers of edge variable earlier. And if I'll see, if I'll run this command again to check the if there is a missing value or not. So here we are done with missing value. There is no missing value here, and the data is prepared accordingly. So like guys, here we are done with data, we have prepared the data, we have checked the like missing value, we have done with our, we have treated the outlier or something, and then the final data is somehow prepared. So like we do not have any more things which would somehow would be like it would not help us in predicting, but yes, all the things are taken care of, like missing value and outliers. So like after like before moving into assumptions and discussion of assumptions basically of a logistic regression, so do you guys have any question? Then just come with me, okay? So I'm starting with assumption. So now I'll just try to compare this assumption with linear regression, and I just want some answers. You can just unmute yourself guys, and uh, or you can just text me, okay? So now the first assumption in linear model was like what? It was like somehow the independent variable and dependent variable should be linearly related, right? So let's not go into details of linear regression assumption, but let's discuss this assumption here itself. So the first assumption of logistic regression, we call it binary logistic regression. So the first assumption says binary logistic regression requires the dependent variable to be binary, meaning like the variable which we are trying to predict, that is survived, which has a value of 0 and 1. So it should be a binary in nature, meaning two categories should be there, whether it be yes no, whether it be true false, whether it be 0 1. So it should be binary in nature, the dependent variable should be in binary in nature. The first assumption, it's very simple assumption. It's like, but yes, these assumptions are these assumptions are like somehow asked in interviews. So be prepared and just try to learn more about it. So now second assumption says to me, like logistic regression requires the observations to be independent of each other. In other words, the observations should not come from repeated measures of or matched data, meaning like the observations should be independent in the variables, like in the independent variables it should be independent. So this assumption we have already seen, and we have already many times we have come to through this assumption, independency assumption, so it's fine. So coming to the third assumption, which says logistic regression requires there to be little or no it can accept a little or no multicollinearity among the independent variables. This means that the independent variable should not be highly correlated with each other. So yes, we have seen this multi-collinearity assumption previously as well, right? Okay, okay, Shubham. So basically, assumption two says like like there shouldn't be any dependencies in observations. So like have you like I don't know how much you have worked in time series. So what happens in time series? How do we predict in time series? Basically, each observations is somehow related to the previous observation, right? That means observations are dependent there, right? Yes, no, Shubham. So have you worked any time in time series? Hello? Yeah, Shubham, can you just come with the answer? Like, have you any time worked in time series, or have you? Do you have any knowledge, like how time series works? Okay, I'm unable to filter chat now. Can you just try to speak? Hello?
No, sir.
Yeah, can you just speak? I'm unable to get the chat.
It's very loud outside.
Okay, okay, okay. I'm just trying to explain from my side. Okay, so what happens in time series? Basically, time series, like when we do prediction in time series, there are two variables. One variable is time, and the second is the predicting variable, which we need to predict basically. So what happens now? Each variable, each observations in time series is somehow related to previous observation. How? Meaning is, like let's say temperature. So like temperature is somehow today, tomorrow, day after tomorrow, is somehow each observation are related, right? Somehow each observation is somehow dependent on the other, right? So that's dependency. So what we are trying here to say is logistic regression requires the observations to be independent. That kind of dependencies would not work in this kind of algorithm, let's say logistic regression. That's the entire concept. Am I clear? Shubham, you can text me. Hello. Okay, fine. So if you have any doubt, then you can just come with me again. So I'm just moving into the third assumption, which says that logistic regression requires little or no multicollinearity among the independent variable. We have already discussed multicollinearity in details with the tests and the diagnostic previously. So it's the same thing. It's the same thing, and the same assumptions for like logistic regression. This is the only assumption which is very like same if we compare the assumptions of linear regression. Now coming to the fourth assumption. Like if you remember, if you recall your previous session, and it was a first assumption there, and it says that there should be a relationship between dependent variable and independent variable in like linear regression, right? So here the assumption is the dependency assumption is relationship assumption is there, but somehow it varies a bit. So let me explain how. So logistic regression assumes linearity of independent variable and log of odds. So now let me just clear this point. In the in the linear regression, it was a straightforward assumption that independent variable and dependent variable should be related. There should be a linear relationship between independent variable and dependent variable. Fine, this is clear, right? So now coming to a logistic regression. Regression says there is a linear relationship, right? But between which? Between the log of odds and independent variable. And how do we calculate log of odds basically? How do we calculate log of odds? Like this is the formula basically when we convert logistic regression. This is equation basically, and this is log of odds. Log of p upon 1 minus p. So for every variable, when we convert into log of odds, then there should be a relationship between, there should be a linear relationship between independent variable and log of odds. So here a bit assumption is changing, but yes, it assumes linearity between log of odds and independent variable, rather dependent variable and independent variable, which we have seen in linear regression. This assumption is very important in terms of learning, or in terms of interview practice, like interview like practice, and because this is a bit confusing, just because it's not a linearity of what we have seen in linear regression, but it's linearity between log of odds and independent variables. So am I clear this am I clear with the assumptions? You can quickly just text me like if every points are just clear, so that we can move forward. Okay, fine. So, fine. So now let's define our logistic regression equation. So I think you guys know this, but it's a logit function which is equals to log of p upon 1 minus p, which we say log of odds basically, and equals to its beta naught, that is intercept part, plus like beta 1 into x, which is constant into variable, plus error term. So this is the equation of logistic regression. You can just make a note, or I'll be providing this material, and this is very general question in interview. People interview just ask this question like, what is the equation basically? Okay, now moving into this procedure of testing and concepts of training and why do we do this, we have discussed earlier in the session, but yes, we will try to explain you a bit again. But apart from this, apart from this, in above portion, do you have any doubt until assumption? No. Okay, fine. So every perspective, every scenario we have seen here. So we have seen the assumptions, and we have treated the outliers, and we have treated the missing value, we have visualized the data, we have understood the data. And then now coming to prediction part, meaning let's just divide the data into training and testing set. I'll just repeat the concept of training and testing set basically. So what is training set basically? We have entire data, we are trying to partition the data such that we can make model learn basically in the training data set. And when we have developed the model, we will try to use the new data set, which is testing data set, and try to predict using this testing data set, and we'll check the accuracy. So clear, this is the basically partition we are doing here. This is the concept of training and testing, and it's important in terms of industry, in terms of practical learning, in terms of doing any kind of machine learning algorithm, implementing any kind of machine learning, whether it be in R, whether it be in Python or anything. These concepts remain same. Okay, so these are very important. Fine. So now what I'll do, I'll just start building a model. Now what I'll do, I'll just try to I'm just trying to explain you this the function of logistic regression here in R. So it's GLM, generalized linear model basically, and the argument would be survived, which is our dependent variable, 0 1, tilde sign, which is telling the function that this is basically a formula sign, and we are passing full stop. It says the model that apart from survived variable in the data, all the independent variables remaining should be considered in the model. Also, it's a very alternative approach. We can just put all the variable names manually. Let's say parent children, let's say sibling and spouse, age, and all the variables manually using plus sign. Okay, age plus parent children plus sibling spouse plus and so on, all the variables. So that is little a hectic task. If you want to put all the variables in the model, just give a full stop, and that's it. This is the first argument in the GLM function, which is generalized linear model. And using a separator comma, we'll just pass on the second argument. And second argument of GLM is what we are using a family called binomial. Why? Because we need to predict outcome which is based on two categories. So binary binomial is somehow comes from a concept which has two outcomes basically, right? So that's why we are using family here is binomial. Binomial meaning two. And we have data set which needs to be predicted, which needs which has a variable called survived, which has two outcomes, right? One, zero. And here we are using logic function is basically a link function. We convert it into probability, and we are trying to predict the probability. If it's zero, if it's greater than 0.5, we would consider it's 1 and the passenger is survived. And if it's lesser than 0.5, we would consider the passenger was dead. So, and what data we are using here? We are using data train, which we have developed earlier using the same concept. We are putting the argument as we are considering this number of rows in train data set, and the other number of rows in tested data set. So am I clear with the model arguments, guys? So let's just run this let's run these functions, and let's just develop the model. And yes, I have successfully modeled the Titanic data set. Let's analyze a bit more, and let's come and see the variables, like yes, we have fitted this function, and like this is the statistic basically, mean, median, and quantiles. So now coming to the coefficients, which is very important, and it says, uh, if we judge its significance basically, so it says like, passenger class, which earlier we discussed, is very important. So yes, we can see it's very important statistically. It's very significant statistically. So now, coming to sex variable, as discussed earlier, yeah, this is very important in terms of survived or dead. So now, age is also a very important factor we can see here. But somehow we see that, yes, this is important but not that much. If we consider 95% confidence interval, it's fine, it's important, it's significant. But if you consider 99%, it's not important. Now since we are assuming like, you 95%, so yes, this is somehow a bit important, and we'll analyze more about it, like in later, like if we, when we are doing individual analysis. Now, coming to parent and children, somehow model says that this variable is not at all statistically significant. Fine. So now what I'll do, like I like, am I clear with the interpretation, right? So now, like I'll be coming down and I'll be explaining you. So we have developed the model, we have summarized the model, and now we will check the model's accuracy. Now what I'll do, I'll just, the model has some prediction values, right? So I'll store that prediction value of this model particularly, and will pass a dollar sign, and I'll give that I want to store the fitted values, basically the predicted values, in this variable model underscore predicted. So let's run this function, and again, I'll just, now, since now I'll just show you one thing. So I'm getting an output, I'm getting an output in a continuous manner. If you see, we have, in a continuous manner, we have, like output, like this. These are the probabilities which model has predicted, and we do not want this way. We have to classify somehow into 1 and 0. So what condition we would give here is, we would say, are that, if if this variable model if it's greater than 0. 0.5, then assign that as 1, else assign that 0. So using if else state function in R, we are just classifying into 0 and 1, because we have to compare this through the original data set, so that we can get the accuracy of the model. So what we are doing, just we are using if else statement, and using this prediction value which model has given us, we are trying to just give assign 1 or 0 value based on a criteria of zero point 0.5. If the probability of prediction is greater than zero point 0.5, then it's 1, else 0. So like if I just run this function, and run, and what I'm explaining this thing. So now we have, now listen, see carefully this thing. So we have trained dollar survived. So this is the actual survived data, which actual data has, right? And is I'm passing is not equal to model prediction, which we just classified here into 0 1. So what I'm trying to say is, like, the when actual is not equal to prediction, calculate its mean, right? Through the mean function, so that we can check like how many, like, what is the misclassification basically. So if I run this and I'll just paste the accuracy, so I'm getting the accuracy equals to zero point 0.8. That means 80%. The model is accurate around 80%. So yes, it's a good fit. It's not a overfit, but it's a good fit. So yes, again, what I'll do, as I said, like, we would try to, remove insignificant. So like, guys, clear with this like analysis, how we are predicting the accuracy, and how misclassification error is calculated. Any question why, like, like, somehow, like, if you're not getting this point, or if you're not getting, like, if you're not getting this point, or if you're not getting this point, anything like that, all clear, right? Okay, fine. So okay, fine. So what I'll do now, like I'll just pass the significant variables now, and there were four significant variable we have seen, and we are passing these four variables, and with the same arguments like this, and we are trying to predict, and we'll again try to calculate the accuracy, and we'll see like how much that variable was important. So if I run this, and we'll check the accuracy of the model, and it says like it's 0.79. So putting that variable or not putting that variable doesn't make that much difference in describing the dependent variable. So now let's make a prediction of the data set we divided into, and if I'll just run the model of using the test data basically, then we'll get like accuracy of this much, which is a good fit again. So yeah, this is the entire end-to-end prediction of using logistic regression of a titanic data set. And yes, this is it. So guys, if you have any doubts, concerns, you can just come now. Since we have done the end-to-end prediction of Titanic dataset using logistic regression. So any doubts, you can just come with me now.